learners, a very warm welcome to all of you in the MOOCs of Emerging Technologies in Energy Resources. I am Dr. Shweta Tripathi from School of Engineering and Technology. You have already learnt about the various energy resources that are available, renewable energy resources that are available, and in this particular module we are going to discuss about various emerging technologies in renewable energy system. And in continuation to these renewable energy systems, we have already discussed in our previous modules about ocean thermal energy system. Now we are going to discuss about the geothermal energy systems also. This is also an emerging renewable energy technology. Geothermal energy. The word geothermal comes from two Greek words. One word is geo, another is thermi. Geo means earth and thermi is the heat. It means we are going to utilize the heat from the earth for serving the purpose. So this geothermal energy is the heat that is coming from the earth. Now, as you have learnt about various energy resources, and in each and every energy resources there are some conversion processes. Now in this geothermal energy, the resource that we are utilizing is inside the earth, and this source lies 6,500 km beneath the earth's surface. At this level of the earth's surface there is a core which contains hot magma, and surrounding of this core is the mantle, and outer layer is the crust, which is known as earth crust as well. And this crust is not a solid shell, but it is broken into many pieces called plates, and the magma comes close to earth's surface near the edges of these plates. Now if we talk about these plates are tectonic plates, and we will be discussing about these tectonic plates later. Now rocks and water beneath the surface around these regions generally absorbs the heat which is available with the magma. So whatever heat of the magma that is absorbed by these regions is used for the conversion of geothermal energy into useful work. Now how we are going to extract this heat? So to extract this heat we can dig wells and can use this heat for various purposes. So if we talk about the history of geothermal energy, that how we have started to utilize this geothermal energy, it is very ancient. So generally the use of geothermal energy for heating purpose is not new, but when we talk about the conversion of this geothermal energy for the electricity, it is a new concept. Actually the ancient people used it for heating and bathing through hot springs at very ancient time. But using this geothermal energy to the production of electricity is all total a new technology. It is a new industry and many advances are going into it. How we have to extract the geothermal energy, and then how we are going to convert it into the electricity. Both are new concept and various emerging technologies are available here. If we talk about the history, it starts with the Italy. A group of Italians first used it in 1904. The Italians used the natural steam which was erupted from the earth to power a turbine generator. Now where do we find geothermal energy? So finding the geothermal energy is also a difficult task. If we talk about some visible features of geothermal energy, Then these are the volcanoes, hot springs and geysers, fumaroles, etc., which are available in India as well. Many of the hot springs are available in India. So we can also extract the energy for geothermal energy generation. But we cannot see most of the resources for geothermal energy production because they are deep underground, and to explore these resources we have to do digging, etc., and then we have to test temperature also. So if we talk about the exploration, it will be done by digging well and then testing temperature, which is deep underground or deep beneath the earth's surface. Most active resources are generally found along the edges of the tectonic plates. Now, what are these tectonic plates and where do we explore them? So if we talk about these tectonic plates or plate tectonics, then the Earth's outer shell, which is divided into several plates that glide over the mantle, the rocky surface of or the rocky inner layer above the core of the Earth. So the plates act like hard and rigid shells as compared to Earth's mantle. So this strong outer layer, which is called the lithosphere, also is there. So the strong outer layer is generally known as the lithosphere, and the Earth's lithosphere is generally composed of 7 or 8 major plates and many more minor plates are also there. So these 7 or 8 major plates generally act as the tectonic plates. So why these tectonic plates are important? Because the lithosphere is a rigid outermost shell of the Earth, that we know, and it is broken up into the several other plates or several plates, and this is known as the tectonic plates. Now when these plates meet their relative motion, it determines the type of the boundary of these plates. Like it could be convergent plate, convergent, divergent or transform, whatever it could be. So there are various kind of tectonic plates depending upon their boundaries. Now the volcanic activity, earthquakes, mountain building and oceanic trench formation occur along these plate boundaries. Now the relative movement of these plates typically ranges from 0 to 100 mm annually. So if we measure or if we explore that how much relative movement is there, so it will depend upon the boundaries of the plates, and according to it, it varies annually. Then an area which we call as ring of fire, where most of the geothermal activities are, we call this area the area of ring, and this is generally the border for the Pacific Oceans. Now how we are going to use this geothermal energy? Because depending upon our end use, we can select the conversion process. So if we want direct use, then it is geothermal heating and heat pumps. If we talk about indirect use, it is the electricity production. Depending upon the form of energy that we need at the end, we will select the conversion process. So for direct use, what we do, the heat that is available beneath the earth, that is geothermal energy. So thermal energy that is available with the earth is directly used for the heating purpose, And what we do in this process, the heat is generally extracted from low temperature source. Generally the temperature is below 150 degrees centigrade for the direct use. And we can use this heat for space heating, we can utilize it for industrial processes. Many of researchers have utilized this heat even for drying the crops. It is used for melting the snow also, and hot water supply could be done with the help of this kind of geothermal energy, or in the application for the direct use. For space heating we use heat pump. So it is also in the direct heating concept only, because heat is generally we are taking heat, but some external energy will be provided there to the heat pump also. So it uses little energy for heating, so thus it saves money and reduces the pollution also for the direct use. Now if we talk about indirect use, and for this the end energy resource, the end energy form that we want or we desire is the electricity. So we utilize this geothermal energy for the electricity production as well. Now here the source temperature will be higher than 150 degrees centigrade, and to extract this thermal energy we have to dig deep wells. So deep wells are drilled and steam from the reservoir is used to drive turbines, and from the rotary motion of this turbines the electricity is produced. It means the process that we are using here is same as other power plants. The drive for the turbine or the production of steam is done by the heat that is available there. Now if we talk about types of power plant, we have flashed steam power plant for geothermal case. So flashed steam plants, dry steam plant, binary power plant and hybrid power plant. So it is for the geothermal energy. So now flashed steam geothermal power plant. In this kind of power plant, hot water at very high pressure is released from deep reservoir and forms high pressure steam. And this high pressure steam is known as flashed steam, and then this steam is used to drive the turbines. So actually the turbine needs steam in coal based power plant also, in other power plants also. So here the steam is produced by the heat that is available by the geothermal energy. So this is the most common type of plant that is operating nowadays for the geothermal case. Now another kind of plant is dry steam plant, and usually what we do in this kind of geothermal plant, geysers are the main source of dry steam. Now there are many properties of these dry steam, and the reservoirs which produce steam with very small quantity of water use this type of plants generally. So we need very small quantity of water for this. Now several rocks may come with the steam or with the water. Then to protect the turbine from these rocks which are coming along the turbine, we use generally a rock catcher, and these rock catcher traps the rocks that are coming along with the steam, and then they will not go to the turbine. So in this from this we can protect our blades of the turbine. Then comes the binary power plant. Binary means some change should be there, two things will be there. So in this kind of geothermal, water is passed through a heat exchanger and its heat is transferred to a secondary liquid. So binary means here we are using two liquids, one will be the primary and one will be the secondary one. Now liquids which are having lower boiling points are generally used as the secondary liquid. So for example, we can take isobutene, we can take isopentane, or even ammonia water could be utilized ammonia water mixture could be utilized as secondary liquid in binary power plants. The vapor that is created or that is produced from this secondary liquid is used to rotate the turbines. So the steam that we are going to utilize here is generally the vapor of the secondary liquid. Other secondary liquids we have already discussed. So this binary system is very useful in geothermal reservoirs because they are relatively low in temperature. Okay, so this system is generally useful for the geothermal reservoirs. Now the heat loss is also minimum here. Why? Because this system is completely closed. So here the loss of energy is also low. So we can say that it is an efficient thing. Then hot water that is here, that is available there, is again recycled back to the reservoir. So again we can utilize the hot water that is available in the reservoir, and the working fluid is also condensed back to the liquid and used over and over again. So recycling is done here. In this case, liquid is also recycled and the hot water is also recycled. Then comes the hybrid power plant. If we talk about this hybrid power plant, it uses both. Both means boiling water and steam. So in hybrid power plant we uses boiling water and steam both, and steam is directly used as we were using in the flashed steam geothermal power plant. So in this case, in hybrid power plant, we are using the energy of hot water through secondary liquid, okay, and we are as we were using in the binary system, and at the same time we are using the enhanced, we are using the flashed steam as well. Now comes the enhanced geothermal system. It refers to a variety of engineering techniques that is used to artificially create hydrothermal resources. So the resource that we are going to manufacture is similar as geothermal energy, but we are recreating it artificially. And in this, the drilling is done in hot dry rocks and cold water at high pressure is pumped inside. Then what we do, this water which is traveling through the cracks in hot dry rocks, its temperature is increased, and when the temperature is increased, what will happen? The water will be very hot, and then this very hot water is collected back through another drilled hole, converted into steam, and then this steam is used for the driving turbine and production of electricity as well. Now this technique is very promising technology, but it is still in its development stage. We are working over it, many of the scientists are working over it, and once this technology will come, we can artificially create geothermal energies. And this technology is very helpful because the risk of seismic activities could be increased due to artificial fracturing the underground rocks. So despite its advantages, there are many risks involved with this, so it is limited. Now if we talk about the advantages of this kind of power plant, so advantages are that the geothermal energy does not produce any pollution, and carbon dioxide emission is very less, so it does not contribute to the greenhouse effect. Why? Because no greenhouse gas is released when we are producing energy from the geothermal energy. And the power stations are compact, so there is not much impact on the environment as well. Carbon footprint we are also saving. Okay, so there are no carbon footprint. In this whole method you have seen that no fuel is used. We are using secondary liquid etc., but they are not used as fuel. So if fuel is not there, combustion is not there, then no harmful gas emission is there. Now once you have constructed the geothermal power station, the energy is almost free. Initial investment is more, but after construction there is very less cost involved. It may need a little energy to run the pump, but this can be taken from the energy that is being generated from the geothermal energy. So if we talk about the net energy, then to run pump also very few amount is required. Then comes the cost, prices and challenges that we are facing for geothermal energy. As we discussed that it does not use any fuel, hence its cost is unaffected by the price fluctuations. Otherwise, for many energy resources, even for the power plants, the price of coal is increased, then the price of electricity will be increased as well. If we talk about diesel power plant, the oil prices are increasing and they will fluctuate the price of geothermal energy. So primary prices are bit high, but once the capital cost have been recovered, the price of power can be decreased. So only initial cost is more in this kind of power plant. Most of the cost in this kind of plant is related to resource exploration and plant construction. Exploration is very costly in case of geothermal power plant. Drilling cost alone account for as much as 1/3 of the total cost, because these rocks in geothermal areas are usually very hard and hot. So extreme hard and hot, and then when we are going to explore these things, it becomes really very costly. The geothermal power plants must be located near a reservoir, or because it is really difficult to transport the steam or hot water from one place to another. So we have to construct these power plants near the reservoir so that we can decrease the transport. No, it is not to decrease the transportation cost, it is to decrease the transport of steam over distances, because it is not possible. Heat transfer may take place and the steam will be cooled down. Then the potential barriers that are there, that this kind of technology is not in use nowadays, or it is not finding its place. So first is finding a suitable location. We could not find the suitable locations from where we can say that yes, we will get geothermal energy here. Then the exploration stage, it can be extremely capital intensive and is of high risk as well, because we have to deal with the hot magma and all, so it is of high risk also. Then apart from this, some areas of land may have the surface that contain sufficient hot rocks which can supply hot water to a power station also. But many of these areas are located in the harsh areas in the world. Generally it is near the poles, or they are high up in the mountains. So how we can explore them is a difficult task. Then if we dig wells, etc., so many harmful gases escape from deep within the earth. Then what we will do to avoid these gases? That is another challenge. If we talk about the resources that are available in the world for this geothermal, then 10,715 megawatt of geothermal power in 24 countries is available, is online. US has generated power from the geothermal energy, and it is leading the world in the field of geothermal energy production. It has 3086 megawatt of installed capacity from 77 power plants that are available there. If we talk about other geothermal energy plants, the Philippines is second one all over the world, or we can say it is after US for the highest production of geothermal power in the world. It has 1904 megawatt of capacity that is available, and geothermal power makes up approximately 18% of the country's electricity generation in the Philippines. Now if we see that there was expected rise to 18,500 megawatt by 2015. Many projects were under construction, but still they have not reached this level. So the level that we were expecting to reach as 2015 is still not achieved. If we talk about the geothermal resources that are available in India, then we can say that India has about 10,000 megawatt equivalent of geothermal power potential, which can be utilized for the production of electricity. But in India, we are still in the developing stage. We have more than 300 hot spring locations which have been identified but by the Geological Survey of India, and they are grouped into geothermal provinces of India, and large investment, and the investment has been done for the exploration of these energy resources already. And now this geothermal energy is going to produce power in India also, but still we have not get that much power. Now if we talk about the geothermal and its effect on the environment, as it does little damage to the environment only. Why? Because very less carbon dioxide emission is there. You can say that no carbon dioxide emission is there. But when we explore this energy, some harmful gases are escaped there. So very small emission is there. The transportation of fuel is not required because they are located on such place that the things are available nearby, because we cannot transport the steam, so it is there. So this geothermal energy need minimal land. So if we talk about the minimalism, then it is also a good choice. Then this geothermal plant use 404 square meter per gigawatt hour, while if we talk about the coal facilities, it need 3,622 kilometers. If we talk about the wind farms, they need 1,335 square kilometers. So in comparison to this, geothermal energy takes very less. If we talk about the uses of fresh water that is required by other power plant and geothermal power plant, so we can expect only 20 liters of fresh water per megawatt per hour generation of geothermal energy. While for nuclear, coal, etc., we need 1000 liters per megawatt hour. So the uses of water is also less there. So we can say that electricity production through geothermal energy is an eco-friendly energy generation system. So we can utilize this kind of energy for the production of electricity. Now let us discuss whatever we have discussed in this particular session. So a brief summary about this session. So we have discussed that what is geothermal energy, what are the various sources of geothermal energy, how could we explore these geothermal energy resources. Apart from it, we have also discussed about various kind of geothermal energy power plants. We have discussed the salient features of these kind of power plants. We have discussed the availability of geothermal energy resources in India. We have discussed about the history of geothermal energy and the status of geothermal energy throughout the world. Thank you very much.